Okay, so I'm going to show you how we split up a vector diagram. When we're given a vector and we want to split it into two parts, basically, into the vertical and the horizontal. So when you're given this, you might be given a line drawn out for you. You might be asked to draw some lines on there. You might be asked to draw the vertical and horizontal and work out the vector. But whatever you're asked to do, basically you're following the same sort of process. So in this case, you've been given the line drawn for you and told that is 31 newtons, that line there. So that line, the length of that line is representing 31 newtons in a direction of 30 degrees from the horizontal. So we can split this up into, basically we're going to say that instead of this line here going that way at 30 degrees, split that up into one force pulling up straight up vertically and one force pulling straight across horizontally. And to do that, we're going to split this force up by drawing it into a triangle. So we have got like a force actually going up here, okay, and then the same thing going across there. But to make it easier when we're drawing it, we're going to draw it from the end straight down. We're going to turn it into what is basically a triangle. Okay, so we've now got one force going up there and another force going straight across here like that. Now, next step, so we've got our triangle, and next we want to work out how much each of these lines is worth. So how many newtons is each of these lines worth? Okay, so we've got our vertical and our horizontal. So to do that, we need to work out what our scale is. Now again, if you were drawing this yourself and it didn't tell you how big to draw it, you could choose your own scale. So just choose a sensible scale, 1 or 2 newtons per centimetre, or 5 or 10, depending on how big how much big the force is you're working with. So for this one, we've got 31 newtons in 6.2 centimetres. Okay, so 31 newtons equals 6.2 centimetres. Now to work out how many newtons per centimetre. So we'll take that and we'll do 31 divided by 6.2, and that will give us a value of 5 newtons per centimetre. Now we can now use this to work out the value of the vertical and the horizontal force as we've drawn them here. So do the horizontal first. Okay, if we measure that, that is 5.4 centimetres, I would say. Then we times that by 5 because it's 5 newtons for every centimetre. So our horizontal force, so I'll call it HF, horizontal force and vertical force, is going to be, do 5.4 times 5 is 27 newtons. Okay, so 27 newtons going this way, and then for the vertical, measure that again, that is 3.2 centimetres, times again by our 5 newtons per centimetre, we're going again from here, and our vertical force equals 16. Okay, so we've split that into two forces, one vertically, one horizontally, telling us how to do that.